So maybe the first question should be, how did the assignment go? Were you pretty successful with your finding the greatest common factor? Because we have to be able to do that, first of all, today, to be able to then move on to factoring the polynomial. So the first thing we'll do is we'll fill in some blanks here where we, it's kind of like the process we're going to do. The GCF becomes a factor, so we're going to find the GCF, and then it actually becomes one of our factors. And then the resulting terms, you know, after we do that dividing that we did yesterday, so the resulting terms, after dividing each by the GCF, those become our other factor. Okay, so we're going to, remember what I said factoring is? It's unmultiplying. It's getting it back to what did it look like before it was multiplied out. So in number 1, when we are going to factor this polynomial 5b plus 9b cubed, that is the result of a multiplication problem. So we have to figure out what was the multiplication problem that it came from. In factoring, one of the reasons that we have to learn how to factor is because factoring is a really important step in when you have to start solving equations that are not linear equations. Once we have to start being able to solve quadratic and cubic and different types in other upper math classes, if you don't know how to factor, it's going to make it that much harder for you to be able to figure out how to solve them. So factoring is, as I keep saying, really, really a big thing. Okay, so we're going to do the same thing we did yesterday. We're going to take the number parts, and we're going to find the GCF. We're going to take the variable parts and find the GCF. Then we will multiply those together, and we'll have our GCF of that polynomial. Okay, so what's the GCF of 5 and 9?
1.
Is there anything bigger than 1? Cody says it's 1. Anything bigger than 1 that divides into both 5 and 9? Okay, so then we're just going to stick with 1. How about b and b cubed? Just a b, right? Yeah, just a b. So what do we do with those again? We take them times each other, and we're going to say that our GCF is
1b.
1b. But you know what? We can clean that up and just make it b. Okay, so we're going to say our GCF is b. Now remember what I said. That is going to become one of our factors. So let's just go right down here and let's write a b. Factor name, we already have one of our factors. It's b. Now we're going to divide each of the terms in the polynomial by that. I want you to put a plus sign over here, because really what we're going to do is we're going to take the polynomial 5b plus 9b cubed, and we're going to divide out that GCF we just found, and the resulting terms are going to be added together in our other factor. So 5b divided by b, what's that? Well, 5 is really not being divided by anything except that invisible 1. What's 5 divided by 1?
5.
And b divided by b? Calvin? Are you here?
No.
No? Could you try to snap to it and come here? Thank you. Join the party. B divided by b is?
B.
1. Anything divided by itself is? 1. Yeah. Anything divided by itself is 1. So yesterday we took this and we kind of broke them apart and maybe divided them separately, but I'm hoping that today you can just kind of do that in your head here. So b divided by b is 1, so we really have just a 5, don't we? So if what you need to do, though, is you need to go over here and write 5b, and divided by b could be written as over b. 5b divided by b could be written as 5b over b, and then notice what happens. Those b's cancel out, and what's left over?
5.
Just our 5. Okay? So now let's go do our 9b cubed. It has to be divided by our GCF of b. So again, if it works for you to do this, if this helps you, go off and write this over here and say, what is 9b cubed divided by b? Well, 9 does the 9 have anything really to be divided by?
No.
Okay, so that 9 is going to be there, right? Okay? And then we ask ourselves, what's b cubed divided by b?
B cubed.
B squared, yeah, b squared. B to the second power. Because what do we do when we're dividing powers with the same base? We subtract. So we have a 3 subtract a 1. There's that invisible 1 downstairs. So 3 subtract 1 is 2. So we have b squared, actually. Okay, so now there is a plus sign between those two. That plus sign is over here. We're going to move it over there. There really is a plus sign between those two terms, the result. So we end up with 5 plus 9b squared. That is our other factor. So when we were multiplying, we actually had times when we had a monomial times a binomial. What kind of multiplication did we use for a monomial times a binomial? What was our typical way of multiplying this type? Distributive property. So I want you to just like right now to visualize, see if you can do it in your head. If we did the distributive property, would it take us back to what we started with up here? So what's b times 5?
5b.
5b, that's our first term, isn't it? Plus, there's our plus sign, b times 9b squared. Well, b squared times b is
B cubed.
b cubed. Now we're adding them because we're multiplying. So that becomes b cubed, and the 9 doesn't have anything to be multiplied by, so it's 9b cubed. Now another thing I need to caution you to do is you might get frustrated when we're correcting and you're like, well, wait a minute, how come I did all the steps that we're supposed to do? But here's what you need to look at. When you are done, so I'm just going to undo that little arm I did there. When you are done, I want you to look at what's in this other factor. And I want you to make sure, I want you just to say to yourself, is there anything that I could still divide out of 5 that I could also divide out of 9b squared other than 1? What do you think? Do you think there's anything else we could divide out of 5 that we could also divide out of 9b squared? So it's kind of like yesterday. Did this ever happen to anybody yesterday when you were looking for the GCF of a number? You divided it by maybe 5, and then you were left with maybe some numbers like, I don't know, 9 and 3. And then you couldn't stop because both 9 and 3 could be divided again by 3. And so then you really could have divided out 2 things. So you really didn't have your GCF until you got both of them divided out. Here's what can happen here. If you don't have the correct GCF, if you did not get a good big enough GCF here, then what your result is going to be is still going to be able to have a GCF taken out of it, some more factors taken out of it. So we have to always ask ourselves, does what I end up with over here, can I do any more to it? Could I have divided more out of it than I did? Okay, so that's a question we always want to ask ourselves. But we can't, so this is our final answer for this one. That's how our answers are going to look today. They're going to look like a multiplication problem that hasn't been done. Questions on that one? Okay, and then I look at number 2, and the first thing I see is that it has subtractions. So what do?
Add the opposite.
Add the opposite. So we're going to rename this as 12x squared plus negative 8x. Don't do these. Don't even attempt to do these, leaving them as subtraction. It works a whole lot better changing them to add the opposite. Okay, so the first thing that we need to do is find the GCF of this polynomial, right? So we need to find the GCF of the number parts and then the GCF of the variable parts. So let's write down GCF of 12 and negative 8. What do you want to use as a GCF for these two? 4. Nothing bigger than a 4? Okay. Then we're going to do the GCF of the variable part. So we have an x squared and we have an x. So we have to figure out the GCF of the variable part. X, okay. So remember now we do what? We multiply those times each other. So now we say the GCF is, what's our GCF?
4x.
4x. Okay. So that's important because in the end we're going to use it. Okay, we don't want to forget about it. So maybe you should put a little star here so you don't forget to come back for it. Don't forget about that 4x. Then next, what we're going to do is we are going to divide each term by our GCF. So we have the 12x squared. Let's put our little plus sign over here, and our negative 8x. Those two terms, we're going to give them each their own line. Each of those terms has to be divided by our GCF. Go ahead, you divide those out and see what you get. What are the resulting terms that you end up with? All I want you to do is the dividing and get the resulting terms. You don't need to go any further than that. Okay, Kelvin, what do you have for 12x squared divided by 4x?
3x to the second power.
Okay, should we agree with them? So 12 divided by 4 is 3. Can we agree with that?
Yes.
Yeah, okay. X squared divided by x?
X.
Can we agree with that?
No.
We need to change it to what?
X.
X. Just an x. Okay. Faith, what's negative 8x divided by 4x? Negative 2. Okay. Can we agree with that?
Yes.
Because negative 8 divided by 4 is? Negative 2. And x divided by x is?
X.
Not
One.
x. 1. Anything divided by itself is 1. And 1 times negative 2 is still
Sorry, it's just
negative 2. No, there's not. There's a difference.
Well, they're not numbers, they're letters.
So those letters don't always stand for 1, though. So now, remember, there's a plus sign here. We'll bring that plus sign over that was over there. Okay. And I want you to write right now in words. You got a few lines left here, don't you? I want you to write the factored name. That's what they're looking for today. They want you to factor these polynomials. So the polynomial, we're just renaming it. We're giving it its factored name. What was it before it got multiplied? And remember, we have a 4x. So our factored name is, we go back and get that 4x that we factored out, that we divided out. And in parentheses, we put our addition that's right here. 3x plus negative 2. But that can be cleaned up, can't it? So we're going to write it as 4x, 3x, subtract 2. That's going to be our final answer.
So you don't want us to solve it? Yeah,
What do you mean solve it?
Like, in the homework, you still want us to solve it, you just want to do it.
Right. We're not doing, what we're doing is we're renaming them in factored form. So if you multiply this back out, where should it go back to?
The original problem.
The original problem, yeah, which go back to 12x squared minus 8x. What are we going to do, though, when we think we're done and ready to move on to another problem? Before we do that, what are we going to do?
To ask yourself, is there anything that 3 can be multiplied, or that 3 can be divided into the same?
Okay, we look at our one that's in parentheses here, and we say, is there anything else that could be divided out of 3x that could also be divided out of that negative 2?
Other than 1.
Other than 1. So we're feeling like this is a good answer then. So let me just show you what I mean by, you need to look and see. Let's just say somebody decided that the GCF for this problem was 2x. Okay? So after they divided their 2x out of their 12x squared, they would have had 6x here, and then plus a negative 4x, or not 4x, just a negative 4, I'm sorry. Okay? So, they're supposed to ask themselves this question. Can anything else be divided out of that part?
Yes.
Is there something that goes into 6x that also goes into that negative 4?
2.
Yeah, we could still divide out a 2, couldn't we? So this would really, so if this was your answer, you'd be like, but I did everything right. Everything felt like I did. I followed the notes, but yet this is the answer you're giving tomorrow, and I get this answer. Well, it's because you didn't really have the GCF, did you? You hadn't divided out enough to start with. So that was why we practiced getting the GCF today yesterday to get ready for today. Okay, let's go to the back side. Okay, what do you think you better do first? Add the opposite. That's right. There is subtraction in this one. So we're going to rename it as 8x to the 4th plus 4x cubed plus negative 2x squared. Now, believe it or not, someday you're going to know how to solve an equation like that. And what's going to help you be able to do that is learning how to GCF it, how to factor it using the GCF method right now. Okay, so we're going to first find what? What's our first thing?
Find the GCF of 8, 4, 2.
Okay, of 8 and 4 and negative 2. We have 3 terms this time, so we need to find the GCF of, we got to worry about every term.
It's 2.
It's 2.
Just 2 goes into 8 4 times, and it goes into 4 2 times, it goes into 2 once.
Okay, negative 2. GCF of, well, we got an x to the 4th, we have an x to the 3rd, and we have an x to the 2nd, our variable parts. No, what do you think that is? Anybody think they know a trick to finding this out? Okay, first, relax. Michaela?
Isn't it the lowest one because you can't take more than you have?
Yeah. It's the lowest exponent because you can't take any more out of it than you have, like Michaela said. So it's going to be the 2, isn't it? So x to the 2nd power, because you can't take more out of x squared than x squared. So the trick is look for the lowest power on that variable. Remember, all those variables have to be alike, though.
2 isn't divided into 3 equally.
Do we have to divide? How would you say, Calvin?
Subtract.
You subtract when you're dividing. You don't divide.
I know, but it doesn't make sense when you do it with the numbers and it has to add up.
Because it's a different rule. How dividing exponents. So now what are we going to do with these guys? Multiply them. 2 times x squared. So our GCF is, what's our GCF? 2x squared. Circle that, star that, don't forget about that in the end. Then we move on to dividing now. So we say we have to take our 8x to the 4th, so I think the best thing to do is just write them down like this. 8x to the 4th plus 4x cubed plus negative 2x squared. So we just take our polynomial and write it down vertically, basically. And then each of those needs to be divided by the GCF. So divided by 2x squared, divided by 2x squared. They better all be getting divided by the same thing, because that's what is going to be one of our factors. So it has to be involved in all of them. Okay, go ahead and get the resulting terms after you divide each of them by their 2x squared. Okay, Julia, what's the result of 8x to the fourth divided by 2x squared? 4x squared. Okay. Cody, what's the result of 4x cubed divided by 2x squared?
2x to the first power,
Oh,
or 2x.
okay. Did you subtract?
Yes.
Thanks, Kelvin.
No,
Okay.
I divided it.
You shortcutted. You subtracted. Aurora, what's the last one's result? Negative 2x squared divided by 2x squared. Oh, what's, first of all, a negative 2 divided by a positive 2? Negative 1, yeah. And x squared divided by x squared is 1, and negative 1 times 1 is negative 1, yeah, negative 1. Basically, if something becomes a 1 when we multiply by 1, it's kind of like we just can ignore it. Bring our plus signs. Bring our plus signs over. And we're going to say that the factored name is okay, so this right here is the other factor.
Is 4x to the second plus 2x
No.
minus negative, or minus 1.
4x squared,
Or 2x to the second power.
our GCF.
Our GCF. And then you start with 4x.
So 2x to the second power, parenthesis,
4x to the second plus 2x minus 1.
so you cleaned it up right away. Are we done? No.
Yes.
No. We got to make sure we can't divide anything out of that factor that's in parentheses. So we look at all three of those terms. We look at that 4x squared, that 2x, and that negative 1, and we say, is there anything else that could be divided out of all three of those? What is that?
It's just 2 of them, you can't do just 2.
So you could take 2 into the 4, and you could take a 2 into the 2, but can you take a 2 into the 1 and get a whole number? No, so again, if it doesn't work in all three of them, then
Doesn't work at all.
we don't want to do it, okay? So I'm thinking that we probably had a good GCF in the beginning, our 2x squared, because now in the end, it looks like we cannot do any more to it. What should happen if I have you multiply that out? What should the result be?
The beginning.
Yeah, we should end up with the original polynomial. It's the same polynomial, it's just a different name for it. Give me an example of me renaming 8 factored. What's a factored name for 8?
4.
Factored
Two
name.
times.
2 times 4. So 8 is the same as 2 times 4. They look different, but they really are the same thing, aren't they? What's another factored name for 8?
2 times 2
2 to the third power.
4 to the second power. No, not for the
I'll take 4 to the second power first. How about 1 times 8? that a factored name for 8?
Yes.
So what we're doing here is we're taking a polynomial and we're just giving it a factored name. It just is a lot more complicated than having to factor something like 8 or 10 or something else. They're just numbers. Okay? Okay, and our last one that we will practice together. We are going to find the GCF of what? Claran, what are we going to find the GCF of first here?
3.
Oh, so what should we do first at this problem? It should be changed to add the opposite. So 3x squared plus 4xy plus negative 2y squared. So GCF of the number parts, and then we need to find the GCF of the variable parts. So x squared and xy and y squared. Go ahead, find those for me, please. GCF of the number parts, GCF of the variable parts.
So for the variables, would it be would it be x1, y1, or would it be just x1?
Okay, so remember when we're looking for the GCF, it has to be able to be
Subtractable.
divided into all of them. Divided or out of all of them is another way to think of it. So whatever you decide the GCF is, it better be able to be divided out of all 3 of those. So what's the GCF of the numbers? 3, 4, and negative 2?
1.
1, okay. How about x squared, xy, and y squared?
Well, xy.
I got X.
You got xy? What else am I hearing? Pardon? Faith says 1.
1 divided by
Faith, could you convince them why it's 1? Because you know what? Kind of lean in towards your answer.
Because if you take x or xy, the x you couldn't divide into y to the second power, and xy you couldn't divide into x to the second power or y to the second power.
And if you picked y, which one could you divide in? Oh,
And the x
x
to the
squared.
second.
So no matter what you try, you try to just divide out some x's, not all the terms have x's. You try to divide out some y's, not all the terms have y's. You even try, you're like, okay, fine, then I'll divide out some xy's. Well, they don't all have xy's, do they? So the GCF is, as Faith said, 1. Well, if the GCF is 1 for both of them,
then it's just 1.
that's 1. And when we say that the best you can do is a 1, then we say it's not factorable. It cannot be factored. Okay, so when this is your result, you would just, there's what you would say. You would say that 3x squared plus 4xy minus 2y squared cannot be factored using the GCF method. And this is important that we include this because we're going to learn another method later that might get us a way to actually factor it. But right now, what we know is in our skill bank right now, it cannot be factored because all we know is try the GCF method. So it cannot be factored using the GCF method. We'll find out later if it can be another way. Anybody have any questions? Okay, let's get going. Let's get started on your home up here.